Unit 7 test review. Number 1. Justin builds a rectangular patio with dimensions of 30 feet by 60 feet. Ethan plans to create a similar patio with the dimensions that are 1/3 of Justin's patio. What are the dimensions of Ethan's patio? Well, if Justin's are a 30 by 60 feet, we need to find 1/3 of 30 and 1/3 of 60 by multiplying. If we're multiplying whole numbers by fractions, remember that you need to make your fraction to your whole number to a fraction by adding a 1 to the denominator. And then solve. 30 times 1 is 30. 1 times 3 is 3. Simplify. 30 divided by 3, which is 10. And then do the same thing for the other. 60 times 1 is 60. 1 times 3 is 3. Simplify. 60 divided by 3, which is 20. So that means Ethan's dimensions are 10 feet by 20 feet. Excuse me. Part 2. What will the area of Justin's patio be? Well, we know Justin's patio is rectangular. The dimensions are 30 feet by 60 feet. We're looking for area. If you look on your formula sheet, area of a rectangle is base times height. So area equals base times height. In this case, our base is 30 and our height is 60. It's okay if you flipped it. I accidentally flipped mine myself. Obviously, the longer part should be 60. Either way, it will equal the same thing. So our base is 30 and our height is 60. All we're going to do is multiply them. 60 times 30 and you get 1,800. So the area is 1,800 feet. And since they're talking about area, our units are going to be squared. Question 2. Find the area of the following composite figure. First step is to break up your figure into two simple figures. I see two rectangles. I'm going to highlight or shade one of them so that I can see the difference in them. Let's go ahead and look at our larger rectangle. If the base is 50 feet, that means this top part right here will also be 50 feet. If the left side is 20 feet, that means this right side right here, from here to here, will be 20 feet as well. Now, the smaller rectangle only gives us a length of 20 feet. That gives us a base. Our base is 20 feet. That means the bottom base is also 20 feet. But we're not given a height. Not exactly. We are given this 30 feet. This 30 feet represents the entire figure. We know that our large rectangle has a height of 20. So from here to here, that's 20 feet. Which leaves us for our smaller rectangle to have a height of 10 feet. After you do that, after you separate them and look at their dimensions, the next step, excuse me, the next step is to solve the area of each simple figure. So we can go ahead and break them up as small rectangle and large rectangle. From the first question, we figured out that the area formula for a rectangle is area equals base times height. That's what we're going to use again here. So for our small, we know area equals base times height. Our base for our small triangle, or excuse me, our small rectangle is 20 feet. Our height for our small rectangle is 10 feet. Plug in what you know into your formula. So A equals 20 times 10, which gives us 200 feet squared. But that's just for our small rectangle. We now need to find the area of our large rectangle. Using the same formula, area equals base times height. This time, our base is 50 feet and our height is 20 feet. Plug in what I know into the formula. A equals 50 times 20. When I multiply that, I get 1,000 feet squared. After I find the area of my simple figures, I have to add those simple areas together, and that creates my total area. So 1,000 plus 200, which gives me 1,200 feet squared. Three, a rectangle is folded along the diagonal as shown below. So right here, this is our diagonal. The measure of angle 1 is 57. What is the measure of angle 2? Even though it doesn't give us a complete angle, if you look, the connections between 2 and 1, right here, it gives us a right angle. And if we have a right angle, that represents 90 degrees, and our two angles are going to be complementary. If angles are complementary, we know that angle 1 plus angle 2 are going to equal 90 degrees. Because we have a 90-degree angle here. I know that angle 1 is 57 degrees. And I'm looking for angle 2. So I'm just going to put an X in its place. My goal is to get the missing angle by itself. In this case, it's X. So to do that, we have to get rid of our constant first. To get rid of a constant, you have to either add or subtract. In this case, we're subtracting since it's already positive. We want to subtract 57 from both sides. And we get x equals 37. So angle 2 equals 37 degrees. Number 4. A triangle and a parallelogram both have the same base and height. If the bases are 9 inches, so let me go ahead and label my bases as 9 inches, and the heights are 5 inches, find the area of each figure and write a comparison statement about the figure's areas. Go ahead and look at your formula sheet, which if you don't have one, a single one in front of you, there will be one in your notebooks. Area of a triangle is half base times height. And then area of your parallelogram is base times height. So let's find the area of both of those. Area of our triangle is half b times h. We are given the information of base times height. Our base is 9 and height is 5. So plug in what we know into our formula. Area equals half 9 times 5. You can multiply your whole numbers first. It's usually easier. So let's go ahead and multiply 9 times 5 first. So we get half times 45. And then our next step is to divide 45 by 2. And then you get 22.5 inches squared. If you remember looking at our area formula sheet, area of a parallelogram is base times height. So let's find the area of our parallelogram. We're given base and we are given height. Our base is 9, our height is 5. Plug in our information. 9 times 5, which equals 45 inches squared. Not only do we need to find these areas, but we need to compare the two. What do you notice about these? Well, it has basically the same formula, except with our rectangle, we have to divide it by 2. That means the area of the parallelogram is 2 times the area of the triangle. All the formulas that you need are given on your reference sheet, so make sure that you are familiar with where they are located. That way it's easier for you to find them during a test. Question 5. Madison traces a circle with a radius of 20 inches like the one shown below. She will only color half of the circle. Find the area of the amount of the circle she will color. Okay, So we have a circle given